This video is going to be about how I have built this short time-lapse animation of the earthquake's location in Greece in the last 30 years. This animation is made for a virtual tour that I'm developing of a geotrail in Psilorítis Geopark. The main point of interest of this trail is the impressive folds visible at the side of the roads that give a great opportunity to talk about the geological processes that gave birth to the mountains of this area. This virtual tour is based on past 360 aerial and ground photos that I have shot along the trail. Now I'm going to enrich and adapt it so it can be played more as a VR experience in supporting headsets like Oculus Quest, Pico VR and more. To achieve this, I have produced 3 non-photographic panoramas by capturing images from Google Earth in a way that I described in a previous video of mine. In these panoramas, I will attach more info that will serve as an introduction to the area. The highest of the panoramas is captured from an altitude of 8,000 meters, and it is there where the link of this video will be placed. To present earthquakes as a phenomena that is strongly correlated with the tectonic movements, I wanted to just produce a time-lapse of known events that occurred around my area of interest, so I started looking up for a global dataset to start with, and really soon I came up with this from Kaggle and the user Alessandro Lobello with a global dataset of the earthquakes from 1990 until 2023 with a public domain license. I downloaded the CSV file and imported it into Microsoft Access to be able to check it, make some changes if needed, and filter it. I could have tried Postgres since the dataset was big, but in the end Access did the job that I wanted. What I wanted from this dataset was a date, a geographic location, and the magnitude of the earthquake. Depth is very important as well, but for the simple visualization that I had in mind, it was not a factor. It is available in the dataset though. After the import into an Access table, I made a query to be able to filter and manipulate the data. The date and time of the occurrence of the earthquake was a form of Unix timestamp instead of a human-readable format. After some digging and testing, I finally found a way to convert it to a valid Access date time field by using a formula like this, but at the same time dividing the number by 1000 because the Unix recorded times were in milliseconds and not in seconds. These values were pasted with patience, since you cannot paste more than 60,000 values each time into a new datetime field. For limiting the earthquakes to my area of interest, Greece, I made a very lazy geographic bounding box to filter only the events that happened in a rectangle that had longitudes and latitudes greater than 10 and less than 50. After that, I re-exported the query back to a CSV format with the filtered values and the new datetime field. My first attempt was to play with ArcGIS Pro, but after making some tests with temporal data and temporal and animation capabilities of the program, I decided to skip it and try QGIS to see if I liked it better. I'm pretty sure that what I produced with QGIS I could have done it with ArcGIS Pro, but again favoring the open source QGIS seems a better approach for me. BottomJS does have functions to create time series and produce animation, and I use them to produce the final one. To do so, I converted the CSV file to a shapefile, and I copied it 3 times into a project in order to make a combination of symbologies to hopefully represent the earthquakes in a better way. One layer was used to symbolize the earthquakes as graduated size dots, using the values of magnitude for size regulation, and one layer was used to create a heat map to indicate the density of the earthquake events over a particular time period. This time period, or step as it called, was 10 days for any particular frame of the animation. For the third layer, I used big yellow star symbols to make it stand out a bit, and these yellow stars are the earthquakes with a magnitude larger than 6. The step for this layer was 4 months in order to stay longer during the animation. All these 3 layers of the earthquakes were activated to display temporal data by using the datetime field. The year was always visible as a title in order to be able, when compiling the animation in a video editing program, to easily add titles that will indicate the year of each frame. I then exported the two layers of the 10-day step as one animation and produced 1239 frames in total. The third layer, with the significant earthquakes symbolized with yellow stars, and the step for 4 months as a separate one. This last produced 104 frames for the same time period. At the same time, these frames are with a black background in order to be overlaid on top of the first ones by using a composite mode linear dodge in order to blend those two animations together. Finishing the compiled animation DaVinci Resolve, I also added the titles to the earthquake events that caused at least one casualty. These earthquakes are the ones that are more publicly known since they had better media coverage. So I will let the whole over 2 minutes animation play now, covering a period of 33 years, and in an area much larger than Greece, of course, more than 75,000 earthquakes will pass. The higher value of magnitude in this period and area were the ones in Turkey in 1999 and 2023 that were recorded more than 7.5.